Hey, hello, and welcome to the show. It is me, John Park, and it's time for JP's product pick of the week here on this very important voting day, election day here in the U.S. So get out there and vote. Go. You can see this later. Go vote if you haven't voted. And thanks for joining over in the chat. I know we've got some people over in our YouTube chat. Hello, Dave Odessa and Quinman16. Doing well, thank you. And Starman says over in our Discord chat, I voted early just so I can watch this show. Well, thank you. Hello, Thin Man. Thanks for stopping by. Squidjet.jpg, Blitz City DRY. Hey, Liz. Hey, Gary Z. Thank you for hopping on over. Hello, Jim Hendrickson. Did I say that? Hello. So I'm not sure if Twitch is running or some of the others because Restream.io UI changed and seems like it's maybe passing the stream along over to some places. Maybe it's not. Let me hit, yeah, it looks like it's running over on Facebook, which gets its feed over from Restream. Who knows? That was news to me. So I'm just going to pause my preview of this, move that over to the side. So my apologies if some of the streaming isn't going to some of the places, but it does appear like we're on YouTube and Facebook at least. So let's get to the meat of this thing. What's going on here? It's the product pick of the week show. I've got a cool new product, something I'm excited about. I want to show it to you. I want to give you a little demo. I want to tell you all about the specs behind it, and I want to give you a huge discount. This show, in fact, runs from right inside the product page, so you can head there. It's product 5990. Use that QR code or that URL right there. And the show broadcasts from inside of the product page. The discount, I'm going to refresh my page to double check, our stock and our price. So yeah, we've slashed the price in half. Thank you to the new product team for taking care of all of this. It is half price, maximum of 10 per customer. We stashed 100 before the show. I think there were some more than that available, so should be plenty to go around. Go there, go to that URL, and you can check it out. But before I reveal any more, as is custom here on the show, I like to present you with Lady Ada from just a little while ago. Take it away, Lady Ada.
Next up, we have an IR transceiver. By request, we have the IR transmitter in the store, and we had an IR receiver in the store, and people were like, well, what do I want both? And I was like, okay, I'll give you both. So this board uses a JSTPH 4-pin connector, which we've often used for I2C. This is not I2C. It's power ground, input and output. And the output is two 940 nanometer high output, like 200 milliampere per LED, horizontal and vertical. And we've got one 38 kilohertz IR receiver. And we've got like two little LEDs at the top to let you know when data is sent and received. So wait, I had a demo and I dropped it. 1 second. So good for good for when you want to do projects that have both infrared remote receiving and transmitting. You do have to hook this up to a microcontroller to decode the IR and also to generate that 38 kilohertz signal. So let's go to the overhead and I'll show this real fast. So transmitter LED, receiver LED, high power and channel FET to drive them, and then a receiver, and then on the back, this is labeled. So ground is the black wire, VN is the red wire. Signal in to drive the LEDs is green, and the signal coming out from the receiver is white. So let's just power it on. So I'm going to use this other breakout kind of as a cheat code. Green LED just means it's powered up. And then if I want to connect the green wire to power, you'll see, well, you'll actually see the in and out because the IR LED, you see them lighting up. It's signaling into the infrared receiver because it's so bright. So this is the transmit. So you would normally connect to a microcontroller and it would blink it on and off very fast. And then to receive data, you use an IR remote, and then you can see the IR LED in LED. That's kind of bright. Maybe I'll shade it over here. There you go. So the in receives data from IR, so you can use both. So good for like projects where you have to like read data in, resend it, you know, you're doing relay, or you just have a lot of remote control stuff you're doing.
Yes, indeed. That's right. That is the product pick of the week this week. It is the infrared IR transceiver breakout. So this, let me show you a down shooter view of the world here. Look at this. Hold that up nice and close. That right there, it is a 38K IR, which is pretty much standard for infrared remotes for things like TVs and stereos. And it has both input and output. So this, I'll bring up this photo, this is a little better. This is pretty cool. So it means we can hook this into a microcontroller, and then you can get power and ground over two of the pins on this big Stemma 4-pin JST connector. You can get an input and an output. So we have a pair of transmitter IR diodes. So those are angled up and out, so you get some massive amount of coverage. And it's high power. And then we have that little dome thing in the middle is a receiver. So you can use this for things like a universal remote that has learning capabilities. If you want to code up something like that, you could have it wait to receive something, stash that away, and then be able to create macros to design your own UI, that sort of thing. Maybe use a touch screen, maybe use physical buttons, who knows. But there are plenty of projects where you want to use infrared. I love using infrared stuff. And this is really nice because it means you don't have to decide, am I going to be receiving on this project only? Am I going to be transmitting? How about both? How about transceiving with infrared? Very cool. So first things first, let's take a look at the product page here. I showed you before, this is product 5990, so you can head on over there. And look at this, we've got it for $2.98, so it's a great price. You probably want to also pick up some 4-pin connectors. Mine are all plugged in, so I won't grab one and show it right now. I'll show you that in the demo. But these links over here on the side will get you going if you want to pick some of the different options we have for 4-pin JST connectors. Just a note, this is not I2C, even though it's using a 4-pin connector in that Stemma size that we often use, that JST connector for things. It's not I2C, it's just a digital I/O pin that can do PWM to send and a digital I/O pin that can do PWM to read. So those are the two pins that we're going to use, not I2C. If you take a look down here, there is a link to the primary guide, which Liz put together. Thank you, Liz. You can see here a typical use. It's being used in a receiver mode, and we have one of those neat little IR remotes, cheap little IR remotes. But you can use a lot of different remotes that you may have around the house already to send messages to this. You can also send messages between them, and I'm going to show you that in a demo. If you have two of these and two microcontrollers, they can be transmitting secret little messages back and forth that you can't see. If you take a look at the pinout here, this will show you options on here. We have the pins on a breakout there on the little connector. We also have pads that you can solder to if you want to put this into a permaproto or a breadboard. And then there are a few different jumpers there. You can disable the power LED, so this will light up a little green LED just when the board has power. And then there's an input and an output LED for activity. Little yellow LEDs, we'll show you those, that let you know when you're receiving or when you're sending. So depending on the project, sometimes if you're doing things in a dark environment like a theater, you may not want to see any blinking when these things are going on. Hint, hint, for magic things and illusions and escape rooms. Sometimes you want to keep the IR a bit of a secret, so you can turn off or cut those little jumper pads there. If you change your mind later, you can resolder them. So this will work with 5-volt or 3-volt power, and you get extra strength on the transmitting with the 5-volt power. And then we've got code examples here. So there is a wiring setup and code example for CircuitPython here. We have a library that makes it dead easy to work with. It's the Adafruit IR remote library, and there's some nice example code for a transmit, a receive, and a non-blocking receive that you can check out. And then there's a really neat example here that Liz put together, which will decode the messages coming from the little IR remote and print those, and then it repeats the signal. It'll send it, I think. Is that right? Yeah. And then this one will send the signal out. If that's not what that one's doing, That's what I made a slightly different version to do that, and that's just to basically act as a relay. If I send a message, it'll receive it, and then a moment later it'll send it. So you could round robin these messages among devices if you want. Yes, yeah, that one's not resending it. I don't know why I thought that. Okay, and then there's a link here on the side for Arduino, so you can get this set up in Arduino using the IR Remote library. It's not an Adafruit one, but there's a simple sender and receiver. And there's a ton of great code out there, particularly in Arduino, but we have some neat TV Be Gone style projects that'll allow you to just send out the power off signal on every known remote standard. If you want to turn off a whole bunch of TVs all at once, you can check that out. And I want to dive into a real world example. So let me set this up. I'll show you what I've got going here. Let me refocus that screen. Whoop. And okay, so what you're going to see here, there's my little IR remote, a little separate one. Here are two pretty identical setups. So I have a Feather RP2040 and another Feather RP2040. This happened to be the prop maker one, which makes it nice and easy to hook up a set of NeoPixels. And then I have running into a little screw terminal Feather wing breakout. And then plugged into pins 5 and 6 for data in and out are two of these IR transceivers. And then they're also plugged into 3-volt power and ground. I'm going to turn these on. So these will both power up. And notice when I do this, you'll see the little green light turn on the board. So that means that the IR boards have power to them. And then what I'm going to do is actually, I'll show you first just kind of a receive demo. So I have a little color remote. You get these with like room lighting things. If I press red there, or green there, or blue there, you can see I've got, I'm going to cover that up for a second. I've got it responding to those colors. And I forgot, my demo doesn't care. Let me hit it with some off there for a second. See if it'll behave. There we go. Hey, stop doing that. There we go. So you can see those were both receiving a signal and turning them one of these colors. I've also got yellow, green, sort of a teal, green, and a pink down there. But then what I've got my code doing is receive a message, check that message and see if we know which button I've pressed and which color that corresponds to, light up the NeoPixels to that color, and then wait a second and turn off the LEDs, set them to black basically, and then resend the message, which means once I get these out of sync, they will send the message back and forth to each other. So to try to make this work, I'm going to cover up one of the, doesn't work, doesn't want to get covered up. Oh my gosh, I can't cover it up. I swear I got this to work earlier. Okay, there we go. So now it's working. Okay, so I have received blue on one of these. I covered the other one up. And then after a moment, it turns off and resends whatever message it just received. Since they both have identical code, they're just going to send this little message back and forth forever. I think I messed it up by allowing some light behind me to shine through. So these should probably be a little bit protected from my overhead lighting. And you can see here, if I hit them with a different color, let me go to some of these other ones. So I can go to yellow here. They are doing a little wait, a little timeout. So one of them will not be receiving while I'm sending the message. Once I get this started, it works pretty well to be able to interrupt it and send it a different color. And here's my little pink there. So waits, sends, this one's going to receive, then it's going to turn off, send, this one's going to receive, turn off, send, off, send, off, send, receive, off, send, receive. Change the color out, do it with red. So let's keep that running, but I'm going to jump over to my code window so you can see how this is set up. So let me go to a less intense color. Let's go over to the yellow. How about? And I can turn off that extra window there. So what's going on here? I've got to use Pulse IO because we're doing some PWM stuff for libraries. I'm bringing in the Adafruit IR remote, And then I'm also using digital I/O to be able to enable pins for power to run my NeoPixels on the Feather prop maker. That's what this setup is here, just to get those NeoPixels going. And then I've created a little dictionary here that is going to correspond certain IR remote codes that I just checked. I can click and see them show up down at the bottom. In fact, if you look at the bottom down there, you can see they just received the OOFF1AE5 code. Send green there. We'll get a different one, OOFF9A65, and you can see that corresponds to the green one. And then I have their corresponding, in this dictionary, hex colors I want to go to. So this is an IR message. This is a color that I can set my NeoPixels to. We are creating the pulse out object as the pin that's going to pulse out infrared at 38,000 hertz frequency, and then the duty cycle. I'm going to set the encoder, which will use the IR remote library to do a remote transmit with certain header specifications, ones, zeros, and trailing. And that's the sort of duty cycle of the square wave pulses that it'll send that are going to correspond to this type of remote standard. And then we're setting up the receiver object, also using Pulse I/O, on pin D5. And we're receiving a maximum length of 120 pulse messages. And we're setting the idle state to true so that it'll wait to receive. And then we're creating the decoder. This is part of the library that actually takes that set of pulses and decodes that into actual IR code. The main loop here, I am checking for pulses and reading them on this IR receiver object. And then I attempt to decode the code and see if it matches something up in this library, up in this input library here. With this, if the code is in input library, then set the color to whatever that corresponding dictionary entry is, fill the colors on the NeoPixels, wait a second, then set the NeoPixels to black, wait a tiny little bit, pulse out the message that we've received and resend it essentially. That will create the pulse array and then do the pulse out send. And then we have a couple of exceptions here to help prevent it from failing. After we've received it, we clear the buffer so that we're ready to receive the next one. So if I start this back up, let me see if I can get them to go out of sync. Cover you. There we go. And now they should send messages back and forth to each other. So 10 meters is the approximate range on this. Thin Man asks, how far do you think you can get them to see each other? Let's test it, actually. I can't go 10 meters away, but let's see if I point the camera over here a little bit. You can keep an eye on one I have just hooked up to a battery, so I'm going to steal this one. IR loves to bounce around, so if I hold this one back here and try to just set one of them, you can see it set both of them, so let me try to hide it behind my back. I'll set that red. There, that one's red, and that one's red. Okay, good. So now they're pulsing each other back and forth. I don't have any fail-safes for when so I'll keep this remote with me, and let's see if I can start it up again over here. If it receives bad messages, I should probably have it try resending the same one that it had last time. Otherwise, they just keep, like a game of telephone, sending a bad message to each other. All right, so I'm over here. Try. Yeah, there we go. So you can see me. Red over here. Oh, it was working, but yeah, the lights are a little intense here. Red over here. Can it get the message over there? Trying. Yeah, I don't have a good way to reset. I think it worked one time. All right, not the best demo, but if you improve your code, you could definitely test out that range a little better than I was doing there. Let's see, other questions. Someone mentioned using it for an infrared harp instrument, IR transceiver to fix electronics. And nice demo, Tackle World, thank you. So let's see, what else to say? Yeah, so we have these different 4-pin connectors, JST, SH, I think it is, or PH. And those come in double-ended, just four connectors, or two connectors of the same kind that you can use to hook them into certain things. I did get this somewhat working on, I think it was a PyPortal or PyPortal Titano that has a 4-pin stemma connector on there. The one of the similar ones was only a single pin of the, because you're essentially grabbing the serial clock and serial data lines off of I2C. Only one of those was a PWM pin on, I think, maybe the Titano. PyGamer and PyPortal also have these pins, but I didn't have enough time to work out some kinks I was seeing in them, so I'm not sure what was making things go funny there. But you're kind of repurposing a pin that didn't really want to be used for that, so I'm not sure. But any digital I/O pins that are really meant for PWM and are exposed like this should work on a bunch of different microcontrollers. Definitely try things like ESP32s, because you can do things like Bluetooth to IR to thing on the other side, or Wi-Fi to IR to thing on the other side, and receive and send messages back there. So let's see what else. I think maybe that covers most of it. There they are. I think if there's no other further questions, I'll wrap things up. So don't forget to head over to that URL right there if you want to go pick some up during the show. You don't need a coupon code or anything. We've just got the discount going during the show. Don't forget to maybe pick up a little cheap IR remote that we have as well. One of these little things are $5. You can use those for experimenting. But any IR remote should work. In fact, let me, before I disappear us, let me turn off one of these. And you can see this is the one hooked up to my REPL. If I send it a code, you can see it said it received the code, and then it's resending that's the non-decoded form of it. Oh yeah, I'm picking up some IR from who knows where, just my lights and things maybe. That's confusing it. So there's a code from this remote, but I can probably, if this thing has batteries, send it things from another remote, different codes. You'll find sometimes codes will overlap. This one overlaps with the little $5 remote that we have. This is a Vizio, an old Vizio TV remote, and you can see using that same NEC format there. So it's happy to grab those codes and spit something out that we could use. All right, let's wrap it up then. So that right there is my product pick of the week this week. It is the infrared IR transceiver breakout. It sends, it receives, it's IR. I will also once again implore you, if you have not, please go out and vote. It is very, very important. And do it. Go do it. Go vote now if you haven't. Thank you so much for Adafruit Industries. I'm John Park, and this has been JP's Product Pick of the Week. I will see you next time. Bye-bye. Pew, pew. Pew, 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 pew.